किया था मैं क्लास के बाद भी।
अच्छा, आज क्या करने वाले हो आप?
अ, अभी ये एक सेकंड। हाँ सर, और इसका रिवीजन करा था।
क्या बोल रहे हो?
जस्ट वन सेकंड सर।
यस यस।
ग्रेविटेशन का।
ग्रेविटेशन का रिवीजन करना है कि प्रैक्टिस करना है?
ग्रेविटेशन आप पहले रिवीजन करके फिर ऐसा कुछ दो तीन सब्स आप दे सकते हो।
ठीक। ग्रेविटेशन, देखो ग्रेविटेशन चैप्टर में पहले तो कंसेप्ट है ग्रेविटेशनल फोर्स का। ग्रेविटेशनल फोर्स कोई भी दो पार्टिकल के बीच में, अगर एक पार्टिकल m1 है, दूसरा पार्टिकल m2 है, both will attract each other with the same force. Direction will be opposite, but the value is going to be same. It means F1 is equal to negative of F. And if I say the magnitude will be equal, and that is given by G m1 m2 by r square. ठीक है?
ठीक है।
After gravitational force, we have gravitational field. Gravitational field. Gravitational field at any point is gravitational force per unit mass. अगर आप ये इसका ये एसआई यूनिट देखो तो ये न्यूटन पर केजी हो जाता है ना? अगर आप इसका एसआई यूनिट लिखोगे, दैट इज न्यूटन पर केजी. If you have a point charge, if you try to find gravitational point mass, and you try to find the field due to this, let's suppose I have a point mass, this is m, at some distance r I want to find field. So field जानने का तरीका क्या है? Just you put 1 kg mass there, 1 kg mass there, and see how much this 1 kg is experiencing the force. That will be the gravitational field. So it should be G into M into 1 by R square. So it is always we write it G M by R square. ठीक है?
ठीक।
If you have a circular ring, let's suppose we have a circular ring like this. In that case, if you are trying to find the field at some point, maybe a ring is having mass m, and this is the radius, and from the center at some distance x a point p is there where you are trying to find the field. So this formula is G m into x divided by r square plus x square to the power 3 by. ठीक है. And it is also the force that this 1 kg will experience toward the center of the ring. अगर आप ध्यान से देखोगे तो रिंग का जो फील्ड का ग्राफ होगा, अगर आप ग्राफ देखो तो कुछ इसका इस तरह से होगा. With x. So first the field will increase, become maximum, and then it decreases and then becomes zero on both sides. Here also it is increasing, but after some time it's decreasing like this. That means there is a point where field is becoming maximum, and at this point the distance from the center is r by root. Here it is plus, this side also minus r by. This is the field versus distance from the center graph. Understood?
Yes, sir.
Then the other important figure is hollow sphere. If you have a hollow sphere, then in hollow sphere there is no field inside. It means that if you take any point, this is inside, the field is going to be zero. It means inside a hollow sphere, any point, field is going to be zero. If you take outside point, let's suppose I take the point here outside at some distance x. In that condition, the total mass of the sphere you can suppose to be concentrated at the center. And then you can use the formula for the point mass, that is outside. Point mass formula we all know. Point mass formula is gm by r square. So total mass you can keep at the center, and you take this becomes here g m by x square. Understood?
Understood, sir.
So hollow sphere is this. Then we have solid sphere.
Or after this, could you let me write from the ring wala part?
See this.
Ah, yes, yes, yes. Yes, sir. Done.
Okay. Then we have solid sphere. Solid sphere. Here inside will not be zero. If hollow sphere graph I have not drawn now, let's draw the graph also for hollow sphere. The graph of hollow sphere is like this. Okay, if the field and the distance x, here there is no field. Field starts from here only and it goes decreasing. So this shows that here there is no field. Here field is zero. And here field is inversely proportional to x square. So that type of graph you get in hollow sphere. Then we can take solid sphere. In solid sphere, if you are taking inside point, if you take inside point, any point, let's suppose I have this radius, you can take as capital R, mass is M, and I take some here point, let's suppose P. Now inside point means you have to find this mass only. M is not we will find because field will be only for this part. Wherever is inside point. So you take the smaller sphere and a smaller sphere mass we have to use. That means here E inside will not be zero. Field inside formula is G M into if this point distance we have taken as X. So G M into X by R cube. That is inside. Whereas if you take the outside point, then there is no change for any outside point. If this point is P, distance is X. So for any outside point, you take the mass concentrated at the center. So and take it as a point mass only. So this will be any outside will be simply Gm by X. So what you can see here that E inside is proportional to the distance X, whereas E outside is inversely proportional to X square. That means if I okay, so if I take uh, a graph here, let's suppose I'll make a graphing of solid sphere. Then what we can see, this is E with X. So first it is proportional, so straight line, and then it is inversely proportional to like this type of graph will come in the solid sphere. This is at the surface, and at the surface you can keep R capital R here, so it becomes Gm by R. Why I'm making it down? Because the direction is always negative, always negative. If X is positive, direction is always negative. Understood?
Yes, sir. Just one second. Yes, sir. Done.
Like here we see variation in the value of G, value of small g. Here also, because Earth is also a solid sphere, so on the surface of the Earth, same formula we will use of solid sphere. gm by r square. That is on the surface of the earth. If you go at some altitude, at altitude h, above the surface of the earth, it means if you take a, this is earth, and you go, are you going like this, and you see this height here, height is only h, this is r. So this is outside point. So outside point, we take the mass and distance from the center. You can use here r plus h square. This way you can find g dash. If height is not that much, for height is less than r, then you can also directly use g dash is equal to g1 minus 2h by r. But this is for smaller height only. This formula is for smaller height. Smaller. If you go at depth d below the surface of the earth, below the surface of the earth, like if I take, this is the earth here, and from here we are going at this point, this is the d. Okay, the center here, distance is, radius is r, the mass is m. Now for this we have only one formula, g dash is equal to g into 1 minus d by r. Minus sign indicates, minus sign you can see here also minus sign is there, and here also minus sign is there. So it indicates that the value of g will decrease. The value of g will decrease with altitude also, with height also, and with depth also. Depth. Understood?
Understood, sir.
हो गया?
नहीं सर, जस्ट एक सेकंड।
ठीक।
यस सर, डन।
Okay, so this was about field. After field, we should discuss about gravitational potential. Gravitational potential. It is actually work done to bring a unit mass, that is 1 kg mass, from infinity to a given point. From infinity to a given point. Like if you have a we can say is infinite potential is v we denote it with potential is total work done to bring 1 kg mass. That means work done per unit mass. If you take SI unit, it becomes here joule per kg. If you have a point mass or point mass, like if I take a mass here as m and at some distance r, a p point is there where we want to find the potential, then this potential will be all it work done is always negative, so it will always come negative minus gm by. If you have a ring, let's suppose I have a ring here, and for this ring I want to find potential at this axis. Axis is at distance x, let's suppose. Here you can take the radius. This distance will be under root r square plus x, and this is the point. So for p here, it is simply gm by this distance you have to take, that is under root r square plus x. That is the potential due to ring. If you have for hollow sphere, for hollow sphere, if you take, then you have few inside, few outside points. Okay.
Oh,
Inside, whatever there are three things. If I say on the surface, if there is mass m and radius r, then potential on the surface is minus gm by r. If you take any point inside the surface, let's suppose I want to find here, this is the point, and here we find the potential. Let's suppose this is the P. So if I say inside the surface, inside the sphere, actually, inside the sphere. So you can see VP is same. Whatever is on the surface, same is there, minus GM by R. Whereas if you say outside the sphere, outside the sphere, outside the sphere, if you are taking, let's suppose I want to take some point here. This is the point, this point Q, and this is at a distance small r. So I'll take the potential as minus gm, but distance I'll take small r. So what you see that these two are same. That means gravitational potential on the surface of of sphere is equal to gravitational potential inside any point, inside any point in the sphere, and both formulas is minus gm by capital R. Understood? We can understand
understood.
the graph also. If this is potential, this is the distance. So we can see that from center to surface, it is constant. Okay, so straight line will be there like that. and this value is minus gm by r up to r same value, and then it gets decreased like this. Then the potential, this is outside, which is radiating. This is for hollow sphere. Or understanding, Neil?
Yes, sir, understood. Yes, sir. Could you scroll down?
Okay. Done.
Yes, sir.
ग्राफ भी ड्रॉ किया.
हाँ, ग्राफ भी ड्रॉ किया.
Now let's discuss solid state. Or let's first discuss gravitational potential energy. It has a simple formula. If two particles are there, this is m1 and here is m2 at a distance r. So it is simply minus g m1 m2 by general formula is that if you know the potential, the gravitational potential value, then you can also multiply with mass. This is also correct. Both formula we use for this. Then we have concept of escape velocity. Escape velocity is that whatever body is on the surface of the earth. Let's suppose earth mass is capital M and body mass is small m, distance is r. So we know that gravitational potential energy on the surface of the earth on the surface of the earth, it will be minus g capital M small m divided by capital R. Now, if you give some kinetic energy so that it goes to infinity, escape velocity is what? It is minimum velocity. Minimum velocity given to the particle, given to a particle, so that particle goes to infinity. It means particle crosses the gravitational field of gravitational field of earth, and at infinity they have no energy. Initially they have potential energy minus g m m by r. You have given kinetic energy half m v escape velocity, and at infinity there is no energy. So you can take half m v square is equals to g capital M small m by r. This gives you the formula of the escape velocities under root 2 g capital M by r. I think you also know that small g is equal to g capital M by r square. That gives you capital Gm. We can write it small g r square. So this formula I can again write here. V escape equals to under root 2 small g r square by r. So escape velocity का एक ये भी फॉर्मूला होता है अंडर रूट जी आर. आप ये भी लिख सकते हो और आप ये भी लिख सकते हो अंडर रूट 2 कैपिटल जी capital M by R. So this is in terms of capital G, in terms of small g. Understood, Neil?
Understood, sir.
स्क्रॉल करूं?
हाँ सर।
Okay. After escape velocity, just a minute. After this, we have satellite. Satellite is anything that orbits near the surface of the any planet. So if you have, let's suppose this I take as the planet M, and around it I'll take a satellite that is orbiting. So here if I take, let's suppose this is the center here. Radius you can take as any satellite will have its any planet will have also have its what we say, its radius also. Let's suppose radius is r and this is called as height h. Then the orbital radius हम लोग क्या लेते हैं, we take r plus h. ये समझ में आया नील?
हाँ यस सर, समझ में आया।
सो अगर आप यहाँ पे हम m लेते हैं एंड इट इज मूविंग विद द वेलोसिटी v नॉट, then the centripetal force it will get by the gravitational force of attraction. Gravitational force of attraction will be G capital M small m by r square, and that will give its orbital velocity. Here v naught is orbital velocity. So m we can cancel. So v naught it will be mb square not by r, also one r will be cancelled. V naught will be under root capital Gm by r. As before I said that small g is equal to capital Gm by r square. So capital Gm always you can replace with small g r square. That means this V naught will be also, we can say, small g r square by r. here, what is small r? I told you small r is capital R plus h. That means the formula for outer velocity, it will be small g r square divided by r plus h. Now, here one condition may be that if satellite is close to the earth, if satellite is close to earth, that means h you can ignore, h you can make it 0. So in that case, orbital velocity will be under root g r square by r got cancelled. So v naught is actually under root g r. Under root. Okay,
Oh,
clear?
clear.
Please write it.
Yes, sir, done.
Okay, you try to solve few questions on this, right?
Right, right.
and whatever question you are solving, you send me also. Okay. After
Okay, sir.
solving, after solving, send it to me.
Okay. Okay.
Bye.
Bye, sir.